Welcome, and thank you for joining us. Today, I'll introduce you to APT Virtual IP Codecs, a future-proof, scalable, and resource-saving solution. We'll explore how virtualization is transforming broadcast environments, providing greater flexibility, efficiency, and cost-effectiveness in content distribution. Let's dive in and see what makes these codecs a smart choice for modern media networks. Let's explore the benefits of virtualization, a major trend reshaping the broadcast industry's approach to infrastructure and scalability. Just as we're used to using one hardware platform for multiple software applications, virtualization extends this flexibility to IP codecs. With virtual IP codecs, we gain rapid deployment, centralized management, and seamless integration with existing systems, which not only reduces complexity but also improves operational efficiency. A key advantage of virtualization is scalability. By simply adjusting licenses, we can expand the number of audio channels quickly and easily without needing additional rack space or extensive cabling. The infrastructure remains stable, but its capacity grows with your requirements. Virtualization also brings unparalleled flexibility in channel assignment and routing, allowing for quick adjustments to meet changing needs and making it ideal for dynamic broadcasting environments. Finally, energy efficiency has improved significantly. Minimizing hardware reduces unnecessary power supplies, lowering energy consumption, and supporting sustainability goals. Let me introduce you to the virtual APT IP codec software. This solution takes the proven performance of the APT IP codec and brings it into the modern, flexible landscape of server environments. By optimizing it specifically for servers, we ensure the codec's reliability and quality, now with even greater adaptability for today's technological demands. One of the standout features here is containerization. This means the software is designed for streamlined deployment, making it faster and easier to roll out across various setups. Plus, containerization brings scalability, letting you expand usage effortlessly, and it provides portability, allowing seamless transitions across diverse platforms as your infrastructure evolves. Another core advantage is that the software is hardware agnostic. What does this mean? Essentially, it operates smoothly across any compatible infrastructure, eliminating the need for dedicated hardware and giving you the freedom to choose the best available systems that suit your needs. The virtual APT IP codec software is extremely flexible in terms of hardware scaling. Whether you're using a single PC or have an entire high-availability architecture in place, this solution can adapt, allowing you to scale as needed. You can start small and grow over time without replacing or redesigning your setup. Finally, we've built in robust redundancy features. This ensures that you maintain continuous operation even in case of hardware or software issues. With intelligent failover mechanisms and seamless backup, you're covered for reliable performance with minimized downtime, which is especially important for critical workflows. On this slide, we're showcasing a highly redundant configuration of the high availability HA architecture. This setup is designed to ensure near-continuous operation, aiming for an impressive 99.999% uptime. To achieve this, the architecture relies on a high availability cluster consisting of at least 3 identical worker nodes. These nodes form a quorum, working alongside distributed control planes to maintain stability and resilience in the system. Now, let's look at the uniform nodes. Each of these nodes is identical in both design and performance, which is critical for consistency and load distribution. Every node hosts pods that contain the audio codecs and the Kibio GUI, ensuring each node is fully equipped to handle the system's tasks seamlessly and without interruption. The last key aspect is failure response. The control planes are set up to monitor each other continuously. This way, if one node fails or encounters an issue, the system responds instantly. The control planes detect the failure and immediately reassign any active codec tasks to another node, ensuring that there is no disruption in service and that the workload is maintained across the network. Let's go through some key aspects of the virtual IP codec and its application areas. This solution is particularly well suited for both distribution and contribution applications, where it ensures reliable content delivery across various network environments. Moving on to central signal distribution, we find that high-density applications, typically involving multiple codecs in a rack, benefit greatly from a server-based solution. By consolidating codecs onto a single server, we achieve higher efficiency and lower hardware requirements. Next, studio network integration is seamless with this setup, as it fully supports industry standards like AES-67 and ST2110-30. This ensures smooth integration within studio LANs, allowing for consistent signal flow and compatibility with other professional equipment. Now, when we look at gateway codec applications, the virtual IP codec acts as an ideal gateway in LAN and WAN setups. It supports all the major professional audio formats for IP transmission, providing robust and reliable duplex communication across networks. Lastly, we have hybrid configurations. We recognize that server solutions aren't suitable for every location. In these cases, the virtual IP codec is designed to integrate effortlessly with traditional hardware codecs in the field, allowing for flexible deployment across different environments. Here, we're showcasing one of two distinct application examples, focusing on MPX distribution. This setup highlights the virtual IP codec's platform-agnostic capabilities. It can be seamlessly installed on a Windows workstation. This flexibility allows the codec to operate across various operating systems and hardware platforms, making deployment highly adaptable. In this specific configuration, the IP codec software is connected directly to Omnia 9S sound processor software, which processes and prepares the audio signal. The signal flow begins with audio input through the sound card, then passes through the Omnia 9S processor. The processed audio is output as an uncompressed MPX signal at a high resolution of 192 kHz over AES-67. From there, the signal reaches the APT MPX software encoder, which is running in a Docker container on the same workstation. This encoder compresses the MPX signal into the APT MPX format, a highly efficient and ready-to-broadcast format suitable for IP transmission. On this slide, we're looking at a centralized content exchange and distribution architecture designed to ensure robust and reliable connectivity across multiple regions and studios. At the core, the headquarters acts as a central hub for all content exchanges. This setup allows seamless management and distribution of audio streams, making HQ the focal point of control and content flow. From here, content can be managed, routed, and monitored across the entire network. Redundant connectivity is a key feature here. Using SureStream, all regions are redundantly connected to the headquarters, which minimizes the risk of interruptions in case of network issues. This high redundancy is essential for a system that needs to handle content distribution across multiple sites. The architecture also supports flexible routing options, enabling both point-to-point and point-to-multipoint connections. This flexibility allows the system to adapt to different distribution needs, whether it's for single-channel broadcasts or multi-channel, multi-location transmissions. Finally, the system offers advanced grouping and routing capabilities that enable the creation of end-to-end routing configurations. This means that groups of sites or regions can be linked together to enable content exchange between specific regions if required. Here, we're focusing on the critical role of centralized management and monitoring provided by the Kibio management system. With Kibio, all virtual codecs and other media network components are centrally monitored, giving you a complete, unified view of the entire infrastructure. This centralized approach simplifies oversight and helps maintain system integrity. One of the key benefits of Kibio is its real-time status updates. You'll have immediate visibility into the operational status of every audio stream and network connection, allowing you to detect any issues as they arise. Kibio also features proactive alerting, meaning automated alerts notify you of any potential disruptions. This allows for rapid response and helps prevent small issues from becoming major problems, ensuring smooth and uninterrupted operation. Lastly, the system provides comprehensive control over all media components. From a single interface, you can manage, configure, and monitor each element in the network, making it easier than ever to maintain a high level of performance and reliability. To summarize, virtualization with virtual IP codecs offers significant advantages across multiple dimensions. Reducing power consumption and rack space enhances energy and space efficiency, aligning with sustainability goals. Cost savings result from the minimized need for dedicated hardware and simplified management, which reduce both capital and operational expenses. With flexible deployment, these codecs can be deployed on any compatible hardware, whether local or in the cloud, delivering unmatched scalability. Content distribution is also highly versatile, supporting both point-to-point and point-to-multipoint routing for flexible content delivery. Finally, centralized management through the Kibio system provides a single interface for real-time monitoring, proactive alerts, and comprehensive control, ensuring streamlined and reliable operations. In short, virtual IP codecs bring flexibility, efficiency, and cost-effectiveness to modern broadcast environments.